I like them when it comes to also enjoying them on that side of the table. This is really a session about cloud misconfigurations, specifically coming from my own experiences, both as a builder as well as a breaker of clouds. So let's get started. Just very briefly, my name is Karl. I live here right in. Say this one? Oh, okay. Both of them. All right. Double miking. Love that. I'm a consultant. I'm heading cloud security at a consultancy called EPAM. We mostly build things, but I represent the part that loves to break things apart on that side. Mostly I'm working with enterprise customers, mostly within the Azure space. I've been working with Azure since it's being called Azure, but of course I do dabble with lots of other clouds, and all of the things that I'm going to talk about today are very much applicable for all clouds. I do have some examples there at the end that are specific to multiple different environments as well. Very, very quickly, this is about misconfigurations. I know some of the other cloud presenters have talked about this before as well, but I really wanted to set the scene a little bit in here and kind of, I really don't want to talk about misconfigurations anymore, but if you look back what happened 10 years ago, it was misconfigurations that were the biggest sources of all kinds of data breaches. They weren't any type of new exploits, anything that the fancy stuff, the 0 days, anything like that. 5 years ago, exactly the same thing, and now it's still the same thing. I wish we would actually move away from that and actually start looking at something else. But it's still kind of, as we just talked about, it's the human in the loop. It's still the human that is making those mistakes. We are still building those solutions. We are using the out-of-the-box configurations. We are using the defaults. Like it or not, the defaults are not secure for many of these vendors. And even if the individual defaults would be, putting these building blocks together actually makes this into a very much a potential attack path. If you're checking out that earlier Azure exploitation session as well, we kind of started building these attack paths not from a perspective of misconfigured environments, but fully individually properly configured environments. But only when you started to put those together, it actually became a problem here. Just to get us on the same page, misconfigurations, I'll just open each of these up in here. Misconfigurations can be kind of the classic one. I accidentally open up a storage account in my to the public internet. It can be that I have secured it, but I'm secured it using a static key, this kind of legacy authentication, and I kind of accidentally publish those to GitHub. It can be like a Kubernetes cluster that I expose publicly to the internet, that Shogun can pick it up. Anything like that can be classified as a misconfiguration as well. So we're going to do a little bit of a story here. So we are going to look at 4 of these kind of harbingers of doom in terms of misconfigurations in here, and we're going to see a couple of examples of each of these and how to fix them. And I'm going to tie it in the end with some examples and go to actions for blue teamers and red teamers alike as well. I did write this for a little bit of a longer version of a session, so bear with me if the RPM comes a little bit higher. You can always kind of slow it down later in the recording as well. So let's get started. So really these 4 horsemen, or these kind of harbingers of this security or misconfigurations, these are really kind of, from what I see, these are very broad categories, because I really think with these categories I'm going to cover 90%, even higher volume of the typical misconfigurations that you'll see. So the first one that I'm going to show here is really this kind of legacy mindset, this kind of approach that we used to have a specific control that worked very well in our previous environment, but we lifted and shifted not just that application itself, but actually the security controls or the mindset or the security architecture as it is from that on-premises world to that cloud world. This can be, you can see this very well in different access control environments. You can see this in this network environments. Typically, a network engineer or network architect is someone who is very specialized, and if they need to be brought into the cloud discussion, there's not always the same set of skills that are applicable in there. Having that additional context of what can a cloud access control configuration do for my for override my network environment, that's very, very fundamental for not just lift and shifting those cloud network controls, but also other types of controls in there as well. So this can also be, stuff like if you have a static set of firewall rules, or if you have a very heavy process, even if you go for this kind of fancy, shiny network security tools that are out there, even the ones that are kind of by their very name, you put most money, it's kind of named after the fanciest and most expensive neighborhoods in the world. Even then, it's not guaranteed for your safety that you need to actually apply and make sure that those are actually applicable and catching your ephemeral workloads, as well as actually adapting to that environment in that cloud. So a couple of examples on that side, how can we actually start fixing this part in here? Really, it's all about kind of understanding that it's not a static environment anymore. Even if you don't think that you have or even if your enterprise counterparts don't think that you have a fancy environment with lots of deployments, hundreds of deployments per day or anything like that, even if it's somewhat of a static environment from a workload and development perspective, there's still a lot of noise, a lot of things that are happening, workloads being provisioned on and off in very quick fashion compared to our existing previous world and existing controls. So we really need to adapt to that kind of ephemeral nature of those cloud workloads. We need to get away from that kind of agent-based mode. We need to get event-driven, which means that we need to be able to tap into that kind of control plane of the environment that we are working on, whether it's cloud, whether it's Kubernetes, whether it's kind of some of these other orchestration layers that I can put on top of my cloud environments. That's where we need to kind of get into that kind of brain of our operating environment there. And there's a ton of identity-based access control that we can put in place. Identity is typically not ephemeral. It's the network and the actual workload themselves, the compute, that is usually ephemeral. The storage and identity typically are not, at least as ephemeral as these other environments there. And if you are doing your network controls in a very heavy configuration, if you're using like Kubernetes or other type of clusters like that, take a look at some of those service meshes that do a lot of that heavy lifting for you. They tap into that nervous system with stuff like ePBF or some of these other kind of sidecar proxies in there. So that was the first one, kind of that legacy on-premise mindset there. So moving on to this other one that I like to call out, kind of just give them more and more access until they get their job done. Very often, especially when we see these lift and shift environments, but also in environments where there is just a bunch of devs trying to do their best, but they are getting those limitations of the new cloud environment that they may not use, may not know what are the actual limitations in there. They usually end up asking just more and more permissions to do that one action that they are blocked with. And if you're not smart about it, they may get stuck with those most permissive permissions in there. And that's what we want to avoid, of course. And this means a couple of different things when you're looking at user access versus workload or machine access. But in principle, this is kind of this creep of different type of credentials that I'm getting in the cloud. It's additional workload identities that are not getting really used. And it's this additional set of permissions that I'm getting provisioned, even if I actually use only a small percentage of those roles. And you can really get into this kind of analysis paralysis with cloud credentials, because in Azure, like 1,200 roles that are built in, you can have your own custom roles, you can have multiple levels of those role controls. It's very complicated if you want to if you want to be prescriptive of that, if you want to design that upfront. You would rather have a machine looking at this. There's lots of different tooling, both commercial and open source, that are available there that actually take a look at that, what is the actual use of our permissions compared to what's actually being provisioned in there. So that's one main thing in there. Whenever you have an access control in the cloud, there's still a lot of environments that have their own disconnected access control that are key connection string based. Get rid of all of those. There is configuration that you can enforce to actually get out of that out of your system. Always go for a centralized IDP. Azure side, Entra ID. Google side, use your Google identity. Enable AWS. Just use a centralized identity. Pick one. Anyone is better than that kind of disconnected environment there. And whenever you can, go and actually look at, instead of the specific role that you are giving for your principals, whether those users or machines, instead of the role, start looking at very specifically, put that analysis paralysis motion into looking at the scope. Where are you provisioning that scope in, rather than what is the exact set of calls that is needed upfront. You can do that later. You can do that based on the analytics of what's actually being used. And once you know what you're doing on that side, start enforcing that, start actually building all of your identity and access controls through identity and access as code. Build that into a prescriptive language as you can. I don't want to install an update right now for this Lenovo device, so let's see how much we have. Here's a quick example of this kind of identity and access as code. I know it's a dark environment there, but this is a tool, open source tool called Air IAM. This is from the same people that built Checo and some of these other tools nowadays, part of Checkmarks. This basically just dumps all of your existing AWS roles and parses those as as machine readable analytics. Looks at what are your permissions, looks at your logs, and pinpoints. Here's like a root user that I have in here that called booth admin that hasn't been used for 192 days. So that's probably something that we want to get rid of. We want to get rid of those overly permissive users and also those users who are not actually actively using this environment at all, in order not to create those attack paths. There is like commercial tooling in this space. This is called Keem. Cloud identity and infrastructure entitlement management set of tools, but you'll see in all of the CNAP and other tools there's similar capabilities built in those tools as well. And this kind of talk about identity and access control is not only on the side of what we just talked about on that, what is the least permission in the context of Azure or in the context of the cloud world, but this is really all about kind of when we kind of break this mindset of that centralized identity that I was talking about. So this is in Azure, for example, you can create those connection strings. You can have those legacy authentications available for your storage accounts, for your key vaults, all of those services that host your data. They have an alternative method of authentication on the storage side. Typically, you need to actually change the default configuration to either get rid of them or default to those centralized identity providers. And exactly the same thing if you are building in other environments, like a Kubernetes-based environment where you by default have just a set of built-in cluster local credentials, essentially. Just very briefly, whenever you have, this is those classic misconfigurations. Whenever you have any of those storage accounts, buckets, you name it, based on the environment, just remove that default access there. Even if you have a case where you genuinely require a specific environment to be used with a key-based authentication, there's always an alternative. You can lock it down from the future keys. You can make sure that you have compensating controls available there. Most of the time you really don't. And you should use data plane level of role-based access control or attribute-based access control if you're in GCP or AWS, and actually make sure that you are enforcing your network and other levels of controls also in your role assignments as well. All of this should be enforced using policies, and I'm going to talk about policies in a moment later as well. Here's just an example, classic thing. By default, accessible by public. Yes, you need a key, but this is already one level closer in there. And then the last one of these horsemen is really the classic one. Again, I said in the beginning, 10 years ago, I started talking about the misconfigurations when we kind of coined the term as an industry. This is still one of the things that we had back then. This is really all about accidentally exposing us to the public in there. Here's what happens in 5 minutes when you have a container instance running in the public cloud. It's gonna get scanned. There's application level scanning in there. There's pings happening all the time. Whenever, if you have anything that has a port open, of course you're gonna get bombarded. You are eventually gonna get logged in for sure. Just do yourself a favor and go kind of disconnected by default in those environments. So there's a bunch of different things that we can do about these things. We have based on the lifecycle, how we are building this. If we are coming in later, there's a limited amount of stuff that we can change. But if we are starting from scratch from a cloud build-out perspective, of course, securing something before we actually deploy it is, typically seen as the cheapest or the easiest way to do that. How do we do that at scale? It's by enforcing, PRs, enforcing scanners for our infrastructure as code. If we get to a point where we actually have all of our deployments as infrastructure as code, then we can start enforcing tools like TerraScan or other IAC security, static application security, but just for our IAC in there. That's perfect for something that is prescriptive. We can also bring that or shift that left. Tools like Chekhov actually build those same policies and same guidance, even all to the level of my VS Code, so that I can actually teach my developers about this, not just break their builds in there. If you are doing Kubernetes, like many of us are, there's a bunch of other different tooling for that, like kubesec and others. And if you are building this in an environment that has more than one developer, then likely you're going to use some sort of version control. So go ahead and trigger those scans and analysis based on some of your GitHub commit hooks there. So from a toolset perspective, when we are moving away from the deployment, or when we have actually deployed this, now this ephemeral stuff happens. We deployed some configuration, but now we start actually using that. If you are in a cloud environment overall, this current hype term that we use is CNAPP, Cloud Native Application Protection Tool. This really just means that it covers more than just virtual machines. They talk about event-based. There's many different vendors out there. Some are allegedly worth 30 billion. Some are free, and there's everything in between from there. But basically, use either the built-in one that you have on your cloud environment. Typically, that is at least closest to free until you start adding some premium features in there. But at least that gives you that visibility of how is my posture doing. Do I have some of those well-known misconfigurations in there? Again, if you're doing containers, you can get a little bit more detailed. You can add stuff like Falco. Falco uses, actually on the cluster level, actually goes in and does ePPF-based analytics. So anytime there is a call from your container application to the node itself, all of that gets logged in. All of that is something that we can analyze from a security behavioral perspective. If you're more on that kind of inspectional space, go ahead and look at tools like Scout Suite and these others that you can run a little bit of red teaming, but also kind of good kind of posture management for yourself as well. Get to know how is my environment configured. Kind of can also act as a good double check for your CNAPP tooling. Does it actually check what I'm doing? And again, enforce all of this stuff using policies. Policy as code is really one of hopefully the last as code that I'm going to mention. It's really something that you want to use to enforce all of your security controls, not just for the existing ones to audit your policies, but also to prevent this stuff from happening again, so that you can actually focus on the next big things that you have in there. the native policy tools on each cloud providers. There's if you are paying for your Terraform, you can also use HashiCorp Sentinel. If you are on Kubernetes, you can use tools like Kuverno that actually give you that same policy as code approach to be prescriptive of what's allowed and what is not allowed and what is audited and how it is. How do we provide that audit log for our as a proof for our behavior in that environment. So a couple of call to actions here. So from a red teamer perspective, really, just do the simple scan. You may think that this is something that everyone knows, we all know, but there's always, an exception. This is only for 5 minutes, or this is only for dev. No one cares if it's only for dev, if it's when the press hits, no one really cares if you kind of deem it out of scope or not. So just scan those basic stuff: public storage accounts, public container registries, public dashboards from your Kubernetes, all that sort of stuff. And specifically look at those legacy connection methods, connection strings that are not tied to centrally managed IDPs. And getting a little bit deeper, look at your service accounts for Kubernetes, look at your service principals, look at your highly powered and especially overpowered machine identities, and start looking at how often they are used, how are they provisions, etc. And yeah, definitely as a red teamer, your kind of golden nugget is that if you are able to find some of those Kubernetes components exposed to the public in there. Especially if you identify that there's not kind of this cloud provider managed kind of EKS automatic or AKS auto managed environments in there. The more manual those builds are, the more things can go wrong in there. On the blue teamer side, do me a favor, just deploy at least one policy out there. It doesn't need to be something that prevents stuff from happening. It doesn't need to break anything. Just deploy at least some basic level policy which you think no one in their right mind will be doing. You'll be surprised. If you're using Kubernetes, again, I really do recommend you using stuff like Falco. They really give you a good set of tooling from that runtime analytics perspective. Pair that up with something like Kuverno. They have audit-only policies that you can put in place. You don't need to prevent anything, but you get a very good list of things. There's always something surprising, even if you are using that cloud provider managed environments. The first thing my clients always ask, why is this cloud provider's own monitoring agent running as root in here? And then we get to the good discussion there. And start logging. If you're on Azure side, specifically start turning on this graph activity log. It's not the same thing as graph logs. It's not the same thing as activity log. It's a thing of its own that actually pre-packages all of the different activities from all of those different endpoints from all of the tooling perspective. Really great source of tenant level monitoring for your environments there. And do audit those service principals. I really do think most of those are unused, and nowadays we have a maximum of 2 years of their lifetime, but maybe tone it down a little bit more. And yeah, all of us, this is really something that we can all do. Do check if I actually have my logs turned on my cloud environments, and Azure side diagnostic settings, etc. Do check those container images if you have some like credentials in code. Do check if you are running any of those containers as root, and just before you head home or before you head to the after party, maybe log in to the mobile version of your dashboard there, and do check if you can rotate one of those credentials. What happens if I do this on Saturday night? Does something break? And yeah. Maybe just think about don't do it Saturday night. But once you're back on Monday, go ahead and rotate at least one set of creds for me. That's really it. Misconfigurations aren't really bad. Cloud is not the same thing as anything that I see here in person with me, and policy as code is your friend. That's really it. So thank you so much. And if you have some time, then it's a Q&A. As long as until they kick me out. Yeah. All right.
I have one. When it comes to like identity, right? There's typical like users and service accounts, right?
Mm-hmm.
With this like whole push for like AI and cloud, are AI identities treated differently, or are they pretty much like the same sort of like ideas that you put forward, like identity as like code and whatnot?
Yeah.
Is it safe to say like they're managed
Yeah.
the same, or would they be done differently?
Great question. For the recording, I'll just very quickly recap, and that helps me kind of also, if I understood it wrong, then you can correct me. So are service accounts any different when it comes to AI? Not really. The same problems kind of when it comes to this chain of there is a system that uses a system that uses a system. If you do any of those parts custom, if you have some token exchange that you do yourself, those are the parts where you can do things wrong. If you have like an API gateway in front of your wherever you host your model, Bedrock, AI Foundry, any of these other places. The same problems of tagging that identity, like who is the actual caller and what are the permissions in my actual application, and making sure that we disconnect the control plane activities, which is stuff like, hey, I can create a completely new database or a completely new cluster or delete all of these things from this application and specifically my AI application specific set of permissions in there. If you just go like automatically I have all of the permissions in the world, it's going to create you owner, and you're going to use those reuse those same machine identities for both creating your cluster, creating your users, and letting your AI agent use that same tool. That's not what you want to do. Great question. Thanks. Do we have time for one more? No. Oh no, not. All right. We can talk about tooling as I'm getting kicked out. Happy to name drop some others here as well. But I think Scout Suite is the one that I use there for multi-cloud, just because it does cover. It's not the most coverage or most depth, but it does cover the most clouds. So that's great one to get started with. Yeah. Will you stop it?